Imagine a huge space, rock hurtling toward Earth and possibly wreaking havoc like never before. This is not a scene from a science fiction movie. This is a real threat. Asteroid Apophis, named after the Egyptian chaos serpent, will approach our planet in 2029. Will it pass us by safely, or will humanity face disaster? Join us as we explore the painful details of this celestial threat and amazing predictions from experts. In February 2013, an asteroid exploded over Chelyabinsk, Russia, shattering windows and injuring nearly 1,000 people. The event was a stark reminder of the dangers lurking in space. The Chelyabinsk meteor was approximately 66 feet in diameter and entered the Earth's atmosphere at an incredible speed of 42,699 miles per hour. It exploded about 19 miles above the ground with a force equal to 500 kilotons of TNT, 30 times more powerful than the Hiroshima atomic bomb. This incident caused extensive damage and injuries, mostly due to broken windows and structural damage. People were taken to hospitals for injuries caused by the shock wave. Many of them were injured by flying glass as they approached the windows to see what caused the lightning. The Chelyabinsk incident highlighted the unpredictability of asteroid threats. The meteor went unnoticed until it entered the atmosphere due to the direction of its trajectory away from the sun, making it invisible to ground-based telescopes. This insidious approach underscores the importance of improving our detection techniques and increasing enforcement. Now an even more serious threat looms. The approximately 1,100-foot wide asteroid Apophis will fly dangerously close to Earth in 2029. Renowned astrophysicist Neil deGrasse Tyson issued a stark warning about this potential disaster, painting a grim picture of what could happen if Apophis were to impact our planet. Apophis first made headlines in December 2004, when preliminary studies suggested it had a 3% chance of colliding with Earth on April 13, 2029. This caused widespread alarm among scientists and the public. Apophis, also known as 99942 Apophis, was discovered on June 19, 2004 by astronomers Roy A. Tucker, David J. Thole, and Fabrizio Bernardi at Kitt Peak National Observatory. The asteroid is approximately 1,100 feet, 370 meters, in diameter, making it a significant problem due to its size and proximity. The name Apophis was chosen to reflect the potential damage it could cause. Apophis or Apep is an ancient Egyptian deity who represents chaos and destruction and is often depicted as a giant snake. The name is appropriate because an asteroid can cause significant damage when it hits Earth. When Apophis was first discovered, orbital calculations showed a 2.7% impact on Earth in 2029. This initial prediction was alarming because it indicated the very real possibility of a catastrophic event. The potential impact has been compared to the detonation of thousands of nuclear bombs, which could cause widespread destruction and loss of life. This prediction caused activity among scientists and space agencies. Attempts were made to refine the calculations and gather more information about Apophis' orbit to better understand the resulting threat. These efforts included tracking the asteroid using ground-based telescopes and radar observations. Neil deGrasse Tyson, noted astrophysicist and science communicator, spoke about the potential threat of Apophis. In his Cosmic Queries podcast, Tyson, joined by science writer Natalie Starkey, discussed how asteroids may have seeded life on Earth billions of years ago, but now pose a serious threat to human survival. Tyson painted a bad picture of what might happen if Apophis falls to Earth. He described a scenario where an asteroid crashes into the Pacific Ocean, triggering massive tsunamis that could submerge much of North America. The impact would create a crater several miles wide and create waves that would destroy coastal areas. The force of the impact would be equivalent to a nuclear explosion of several megatons, which would cause widespread destruction and could result in significant loss of life. Although subsequent analyses have reduced the probability of an impact in 2029, the trajectory of the asteroid remains a cause for concern.
Scientists have identified a critical region of space known as a gravitational keyhole. If Apophis passes through this keyhole, it could change its trajectory in ways that would make a future impact on Earth more likely. A gravitational keyhole is a small region in space where Earth's gravitational forces can change the orbit of an asteroid passing through it. For Apophis, this keyhole is only about 600 meters wide. If the asteroid passes through this keyhole near 2029, it could put it on a collision course with Earth in 2036. The probability of Apophis passing through this keyhole is low, but not zero. Scientists will continue to track the trajectory of the asteroid to refine their predictions and assess the threat it poses. The potential consequences of the effect make it a priority for continued observation and research. To illustrate the potential destruction, Tyson described a worst-case scenario where Apophis falls into the Pacific Ocean. The impact triggered massive tsunamis that caused walls of water to crash into coastal cities and submerge much of North America. The initial impact would create a crater several miles wide and create waves that would destroy coastal areas. The force of the impact would be equivalent to a nuclear explosion of several megatons, which would cause widespread destruction and could result in significant loss of life. If Apophis fell to the ground, the consequences would be just as dire. The impact would create a huge crater and release an enormous amount of energy equivalent to the explosion of thousands of nuclear bombs. The explosion would cause widespread destruction, leveling buildings and infrastructure for miles. Dust and debris thrown into the atmosphere can create a nuclear winter phenomenon that blocks sunlight and causes global temperatures to drop. The 2013 Chelyabinsk meteor event is a frightening example of how even small asteroids can cause significant damage. The Chelyabinsk meteor was approximately 66 feet in diameter and entered the Earth's atmosphere at an incredible speed of 42,699 miles per hour. It exploded about 19 miles above the ground with a force equal to 500 kilotons of TNT, 30 times more powerful than the Hiroshima atomic bomb. This incident caused extensive damage and injuries, mostly due to broken windows and structural damage. People were taken to hospitals for injuries caused by the shock wave. Many of them were injured by flying glass as they approached the windows to see what caused the lightning. The Chelyabinsk incident highlighted the unpredictability of asteroid threats. The meteor went unnoticed until it entered the atmosphere due to the direction of its trajectory away from the sun, making it invisible to ground-based telescopes. This insidious approach underscores the importance of improving our detection techniques and increasing enforcement. Fortunately, advances in asteroid detection technology have improved our ability to track and predict such threats. NASA and other space agencies are developing tools like the ENEO Surveyor spacecraft to improve our ability to detect and mitigate potential threats. ENEO Surveyor, formerly known as the Near-Earth Object Camera, NEOCAM, is designed to detect and track asteroids that could pose a threat to Earth. By identifying potentially dangerous asteroids at an early stage, we can develop strategies to reverse or mitigate the effects. The ENEO Surveyor spacecraft is equipped with advanced infrared sensors that can detect the heat given off by asteroids. This makes it possible to detect objects that are difficult to see with visible light telescopes, especially those that approach from the direction of the sun. The spacecraft is designed to detect and track asteroids up to 140 meters in diameter, which provides early warning of potential threats. In addition to space-based observatories, ground-based telescopes play a vital role in asteroid detection. Telescopes such as PanSTARRS, Panoramic Survey Telescope and Rapid Response System, and the Catalina Sky Survey are dedicated to detecting and tracking near-Earth objects, NEOs. These observatories scan the sky for moving objects, allowing scientists to identify new asteroids and calculate their orbits.
The threat of an asteroid impact is a global problem that requires international cooperation. Space agencies, scientists, and policymakers around the world are working together to develop strategies to identify and mitigate potential threats. The United Nations established the International Asteroid Warning Network, IWN, to facilitate international cooperation and information sharing. IWN provides a platform for data exchange and coordination of asteroid observations. It also promotes public awareness and education about the asteroid threat. By working together, nations can pool their resources and expertise to improve our ability to detect, track, and mitigate potentially dangerous asteroids. In addition to IWN, the Space Mission Planning Advisory Group, SMPAG, is another international organization focused on planetary defense. SMPAG brings together representatives from space agencies and research institutions to develop coordinated action plans for potential asteroid impacts. This includes developing strategies to deflect or destroy asteroids, Asteroids, often called minor planets, are remnants of the early solar system and contain valuable scientific knowledge. Understanding their composition and trajectory is important to develop effective deflection strategies and protect the Earth from potential impacts. Asteroids are composed mainly of rock, metal, and ice. Their size varies from small rocks to objects hundreds of kilometers in diameter. Most asteroids lie in the asteroid belt between Mars and Jupiter, but some near-Earth objects, NEOs, have orbits that bring them closer to Earth. The study of asteroids provides valuable information about the formation and evolution of the solar system. By analyzing the composition of asteroids, scientists gain insight into the materials that were present in the early stages of planet formation. This information can help us understand the processes that led to the evolution of the planets, including Earth. Developing effective diversion strategies is an essential part of protecting the planet. If an asteroid is detected with sufficient advance warning, there are several possible methods to change its trajectory and avoid a collision point. One possible method is kinetic impact technology, which involves sending a spacecraft to crash into an asteroid at high speed. The collision would change the speed and trajectory of the asteroid and send it past Earth. This technique requires precise calculations and careful planning to ensure that the impactor hits the asteroid at the right angle and at the right speed. Another possible method is to use a gravity tractor. A gravity tractor means sending a spacecraft to fly with an asteroid for a long period of time. The gravity of the spacecraft gradually changes the trajectory of the asteroid. This method requires less force than the kinetic impactor, but takes longer to achieve the desired effect. In some cases, a combination of methods may be necessary to achieve the desired deflection. For example, a kinetic impactor can be used to obtain the initial deflection, followed by a gravity tractor to fine-tune the trajectory. Public participation and education are essential to raise awareness of the asteroid threat and support initiatives to protect the planet. By informing the public about risks and measures to reduce them, we can create a sense of urgency and cooperation. Educational programs and public information efforts can help people understand the importance of asteroid science and planetary protection. This includes an explanation of the possible consequences of the collision, the methods being developed to detect and control asteroids, and the role of international cooperation. Engaging the public also includes encouraging them to participate in citizen science projects. Programs such as NASA's Asteroid Data Hunter allow amateur astronomers to participate in the discovery and tracking of asteroids. By analyzing data from telescopes, citizen scientists can help identify new asteroids and refine their orbits.